let's start. What is physics? I started teaching physics in 2003. I taught math up until then, only math. And so I told my mom that summer, hey, Mom, I'm teaching physics. And she said to me, Kelvin, I know what math is. It's like numbers. What's physics? And I struggled to give her a definition. The definition I've got here is the one that my physics prof told me. He said, physics is the science of measurement and calculating. He said, if you're calculating, if you're measuring, you're doing physics. I kind of like that because it's very broad and I'm a physics nerd. If you're not measuring or calculating, you're doing biology. Oh, sorry, that slipped out. But it leads to an obvious question. What do we measure? The big three. The first one that we measure is length. What is length measured in? What are the fundamental SI units for length? Meters. Now, meters in Canada is actually spelt, and I'm a proud Canadian, but I also know most of you think that looks weird, and so you're going to spell it that way. But it is pronounced Z, not Z, so symbol M. Time. Seconds. I'll just abbreviate S. By the way, if you can't, first of all, Jordan, am I writing big enough for you to read back there? Because I got to get used to I'm not in mid-season form yet. If you can't read my writing, ask. I will never make fun of someone who can't read my writing. My writing is atrocious. It has improved, believe it or not, but there's a reason why I type everything. And, mass. It should be grams, because it should. I noticed this doesn't have a prefix in front of it. This doesn't have a prefix in front of it. Grams would make more sense to me in terms of symmetry, but unfortunately a gram is too small. Yeah. Really, what we should have done if we'd really thought this through, back 200 years ago when they defined what a gram was, they should have actually defined a gram as what a kilogram currently is. That'd be great. That would be it, because like a gram is about a paperclip, which is ridiculously small. Kilogram, that's a good mass to work with. I just don't like the non-symmetry, because here, 2 letters with a metric prefix, ugh, but okay, it is what it is. In fact, there are 7 defined units in the SI, the System International, which every country on Earth but 3 use. Actually, that's a lie. 4 years ago, Bangladesh went metric. So then there was 2. No, that's a lie. 3 years ago, Sierra Leone went metric. And now there's only 1 idiot country that hasn't gone SI units. What's the idiot country that hasn't gone SI units? Oh, you're kidding me. Oh, anyways, from these 7 that are defined, everything else is derived. So all that you learned about newtons and joules and watts, they all come from these 7. We're actually only going to be using the first 4 this year. So anyways, length we already said, meters. Time we already said, seconds. Mass we already said, kilogram. Hey, what are the fundamental SI units for current?
Joules?
Nope, joules is energy.
Watts? Ampere?
Ah, young boss.
Ampere?
Amps. In English we say amps, named after a scientist whose last name was Ampere. So I'm going to write AMPS, capital A is the abbreviation. You'll find, and I'll probably repeat myself when we get to electricity, but you're teenagers and you're dumb and I need to repeat myself. Whenever I give you a new unit, I try and give you an idea of what's really big and what's really small. 0.005 amps, if it was across your heart, could cause your heart to fibrillate and not work properly. It's called the death current. 15 amps is what comes out of the plugs. 100 amps, I think that's around what the electric shares use. Like that would actually cause a human being to start to burst into flame and sizzle and be yucky and disgusting. I will later on this year, near the very end of the year, show you a video of a device with 800 amps, and that's terrifying. Temperature, my favorite unit. What kind of degrees? Not Celsius. Kelvin, what was that? I'm a Oh, yeah. Now, I write, first of all, I'm going to write degrees Kelvin in English because I get to write my name in my notes. Woohoo!
Is it degree Kelvin?
Well,
Because I was taught
now, this is where it varies from North America and Europe, I think. I think in Europe they just say Kelvin and they don't put the degrees. I think because, again, we're the U.S. and the Americans, since they measure temperature in degrees Fahrenheit, but their neighbors to the north measure temperature in degrees Celsius, and the SI is degrees Kelvin. I think in North America we've gotten in the habit of putting a degrees there just to indicate that we're talking about a temperature and make sure you put the correct measuring device. What's 0 degrees Kelvin? It has a nickname or another name. It's called blank zero. What is absolute zero? No. Yes, but no. I'm going to blow your mind, and I'm going to tell you how you can win a Nobel Prize, okay? So, you learn in Science 8 that what we think of as heat is actually just how fast molecules or atoms are moving. And as you cool them, what you're doing is you're removing kinetic energy, and they move less and less. And absolute zero is when the molecules aren't moving at all. But I think it was about 10 years ago, a guy wrote a paper, and he said, well, wait a minute. Whenever you're measuring the temperature of an object, you're measuring an average temperature. Some of those molecules are slightly higher than absolute zero. But if it's an average, and if some of them are slightly higher than absolute zero, some of them are slightly lower. What the heck is that? Nobel Prize waiting for you if you want, okay? He was like, yeah, we never thought of that, but you're right. So they're anyways, working on it. The amount of a substance, you did this in Chem 11 if you took Chem 11. The amount of a substance is measured in?
liters.
No. Begins with an M. Moles. If you've seen one, you've seen them all. Oh, okay, fine. Now, my favorite unit for obvious egotistical reasons is degrees Kelvin, to me, the coolest unit is this next one, because with the first 6, unless you've seen one, you don't know how big one is. In other words, unless you've seen a meter stick, you don't know that it's this big. Unless you've heard a second, you don't know that that's a second. How big is an amp? I don't know. This next one, if I give you the name, you'll instantly know how big one is.
Is it lux?
Nope, that's not that's a non-metric unit. Heard it back there. Candles. Candela, candles. And you all instantly now know exactly how big one candle is, don't you? Yeah, it's that big. I wish more units were like that. That'd be nice. Yeah.
And what are lumens?
It's another way to measure. You're going to find there's other ways to measure things. So, for example, we're going to look at magnetic field. We're going to measure magnetic field strength in Teslas, but it can also be measured in Gauss. It depends on how you're defining it and how you want to combine the units and exactly what you mean by strength. Okay? Because strength could be determined in how bright one small dot is, or you could be talking about how many photons are hitting a given area at the same. It really depends. What do you mean by how strong is it? Candelas, and I believe it's Ca. Sorry, we're not going to be using the bottom 3. We don't look at temperature in physics, in BC physics. You look at it in Science 8, vaguely because it's cool. Moles you guys do in Chem. Okay, that. Light intensity we don't look at. I know it because I'm a nerd. In addition to the base units, the SI system uses prefixes, metric prefixes. So for example, the prefix kilo means times by 1,000, or I would probably write times by 10 to the third because that's less writing, and I'm naturally lazy. So it says complete the chart on the next page. Do you think I want you to memorize these? No, I think that, you know what? On your formula sheet, the chart's on the back page. There is going to be one later on this year that you're going to memorize because we're going to use it in every single question for about 3 weeks straight, and you get sick of looking it up. We're all going to end up memorizing micro because electric charge is measured in microcoulombs because 1 coulomb would kill you. It's just way too big. So let's start in the middle. We have our base units. This is where we have joules or newtons or watts or seconds or kilogram. Oh, no. See, kilo doesn't fit there. Liters or whatever. And let's go up. Deca. I have no idea what the abbreviation for deca is because I never use it. But what is the abbreviation for deca? It's on your chart. Someone look on your... By the way, you might want to have your formula sheet out in handy. I'm just kidding. What is deca? I know there's a D in it. Lowercase or uppercase? Okay. And as a power of 10, that's multiplying by 10 to the 1. Is that right? Is that what your chart says? See, the reason, Tice, that I don't know that is I would never say that's 5 decameters. I'd say that's 50 meters. It's also less writing. So I never use that one. I also never use the next one, hecto. Lowercase h? Is that right? Whatever. And that's a 10 to the second, yeah? Because again, I don't say, oh, the football field is 1 hectometer. It's 100 meters. You'll hear forest fires are often described in hectares, which I'm guessing is a metric thing, but honestly, I'm not sure how big a hectare is. I really should know because the number of forest fires we had this summer. By the way, I'll tell you later, I put out a forest fire this summer. Some idiots on Pitt Lake left a campfire going after a beer party, and I was sailing with a friend. We're by the shore. There's smoke there. So I jumped into the water with a bucket and swam over there and was throwing it. We got helicopter came and poured a bucket over. It was great. That was my good deed for and then the next day, I drove a Tesla. It was like a win-win. What a great day. Anyways. And I'll tell you, we'll look at the Tesla later, and I'll tell you how they work. Kilo, this one I have memorized because I drive. And I know that 1 kilometer is 1,000 meters. You don't have to memorize that one, but most of you either have your license or will be getting your license this year. You will memorize that one just because of road signs and things like that. Mega was important for me, for my generation. When I was about 22, I bought my first hard drive, and it had 5 megabytes. And I thought, well, actually, let me take that back. Kilo was important to me because when I was 13, I bought a Commodore 64, my first computer, and it had 64 kilobytes. How will I fill that? And then I got to Mega. Mega's capital M, yes? I got to Mega, capital M. And wow, this is great. How will I fill that? And I know that Mega is 10 to the 6th. That one I've memorized because of the lottery. There's that Mega Millions lottery. That phrase still goes together in my brain because they're both M. And I know millions is 10 to the 6th, but you don't have to memorize that. That one I just have because eventually I have. Yeah?
Megabytes just like, wow, so much.
Kilobytes was just like, wow, so much. So when I was 13, actually, you know what? Hold that, because when we go smaller, I'll give you another story as well. You guys are sort of the gigabyte generator. Your phones have gigs. What's above gigs? So I have, 2 years ago, a terabyte hard drive right there. That seemed like a lot. What's above teras? Okay. Peta is just starting to enter the consciousness because Google talks about how many petaflops their servers can handle or how many petabytes their servers hold. So probably in about, I'll probably say 5 years from now, you might be able to buy a petabyte hard drive, maybe. After peta is candy for it, if you know.
Zeta?
Nope. Close. So exa comes next, capital E, and that's 10 to the giga, 10 to the 9th, peta, 10 to the 12th, exa, 10 to the 15th. What's after that? I don't know yet. You guys might, because we seem to be making stuff bigger. Oh, another little aside, by the way, for my Europeans versus my North Americans, and if you haven't figured out by now, you're going to get a lot of this in my class. Under hashtag nerd trivia, in Canada, in North America, we go thousands, millions, billions. In Europe, they do not do that. They go thousands, millions, 1,000 million, 100,000 million, billion. A billion is a million million. Now, if you don't think that that leads to some confusion on the world economic stage when we're talking about billion-dollar debts and things like $1 billion debt in North America, BC can handle. In fact, probably Vancouver could handle. $1 billion debt in Europe, the planet could not handle. Anyways, Okay, keep going. Really, even numbers aren't the same? No. Let's get smaller. Deci, I don't know this one because I never use it. Oh, here's the other thing that bugs me. Uppercase, uppercase, lowercase, lower. What? These are big. Why wouldn't they should all be uppercase? If I could change one thing, if they made me premier of the world for a day, I'd change those three. Should be capital D, capital A, capital H, capital, because also Terra is capital T and Peta is capital P and Exo is capital big cap. Come on. Whatever. Things I can control. Deci, is deci just a lowercase d period? Don't care. I would never say that's 1 decimeter. I'd say it's 0.1 meters. But okay, and I think that's 10 to the negative 1 if I recall. Centi, that one I've kind of memorized over the years because a centimeter, I know there's 100 of those in a meter because I grew up in the metric system. So C, I know that's 10 to the negative 2. And I know milli. Mac.
Yes.
I was also part of the micro generation. When I bought my Commodore 64, it was called a micro computer. The reason it was called a microcomputer is the chips were the size of micrometers back then. I was like, wow, the computer had gone finally from having to take up a whole office room to it'll fit on a desk. Wow! We've clearly gone much smaller than that. But if you're wondering why they called them microcomputers, there you go. And the name is just kind of stuck because micro to the non-science public means small, like microscope and things. Oh, smaller computer. Micro is 10 to the negative 6. What's the symbol for micro? This thing, right? What does a Greek cow say? Mew. And it's also the coefficient of friction symbol. I know. We need more letters in our alphabet, but when in doubt, we go to Greek. Smaller than micro, and this certainly has become more prevalent in the last 4 or 5 years. You've all heard about nanotechnology. Mm-hmm. Smaller than nano?
Pico.
Ooh, yes, pico is smaller. Pico is 10 to the negative 12. Smaller than pico?
Femto.
Femto, which is 10 to the negative 15. Smaller than femto? I had to add it to my Physics 11 handout this year because, well, no. I got put your pencils down, look up. Go Physics 11 for a second here. Atto, yes, he looked it up. Oh, is it on there?
Mm-hmm.
Oh, look at that, it is on there, okay. There's a limit to how small we're going to end up getting. So here's the smaller ones. I've reversed it in my Physics 11 notes. Nano, we're talking molecule-ish sized. Pico and femto, we're getting atom-ish sized. I don't think we can really build stuff smaller than an atom. So although I think the bigger ones are going to keep getting bigger in your lifetime, I'm not convinced you'll ever buy an Atto chip, for example. I don't think it can be done. So how small will we get? The other thing is the smaller you get, then you start to run into quantum physics and Heisenberg's uncertainty principle, and it doesn't do you much good if you build something so small but you can't tell where it is. Back to the notes. During this course, we're going to use models, often mathematical, to help us understand a particular set of phenomena. Full disclosure, almost everything that I teach you is going to be wrong. It's going to be garbage. To make the math nice, Attila. You know what? If we throw something, we're going to ignore air resistance because the math gets yucky. Or we'll look at an Atwood machine with pulleys and ropes and masses. Our ropes won't have any mass, and our pulleys won't have any friction, and our pulleys won't have any mass because the math gets yucky. Every once in a while, Lewis, you're going to hear me proudly say, actually, we got everything. This is pretty accurate. But most of the time, to really do it well, you need calculus. But they'll be pretty close. They'll be good approximations, and they'll be the starting point of figuring things out. Since our models will be mathematical, good math skills, I wrote are a must, are really helpful. Really helpful. And I've always found that kids who aren't that great at math get way better at math because physics is not abstract. You can visualize stuff. So here's a review of the basics. One of the things you want to get very good at this year is solving a quadratic equation. What is a quadratic equation? How can I glance at an equation and know instantly it's a quadratic? It's got squared. Thank you. You're the first kid who's done it that succinctly, and that's always my phrase. There's a squared. If there's a squared, it's a quadratic. If there's not a squared, it's something else. There's a squared. How do I solve a quadratic equation? Well, you learned two methods last year. The first is the contrived making up nice numbers to make sure everything works out method, factoring. In physics, because we have to use real world numbers, almost all of ours are not going to be able to factor. By the way, what makes a quadratic? You just told me.
Squared.
Listen close. D equals VIT plus a half AT.
Squared.
That's the quadratic that we're going to be flogging. Mr. Kamosi and I last year picked our numbers carefully in that equation to make sure that you could solve it without the quadratic formula last year. This year, it's fair game. And that's the second method, the quadratic formula. Oh, the quadratic formula, Mr. Dueck. Yeah. So here's a quadratic. Before I even start, what do I have to do to solve a quadratic equation before I even start? Even before that? Make it equal to 0. Okay? And I don't care which side you... I almost always will either choose the easiest, or I'll show you another little quirk of mine in a second. To make it equal to 0, then I would rewrite this particular equation here, and I would go, okay, 5t squared plus 7t plus 2 equals 0. I hope you guys can rewrite things in your head without showing work. I'm perfectly fine with that. Then you're going to hear a phrase from me fairly often. I always say, I want maximum bang for minimum buck. I want to be as efficient and organized and lazy as possible. So here's what I always did, and I'll change colors so it stands out. I did want to be organized, but I didn't want to rewrite a bunch of crap, so I always just did this. I figured that was a good way to label stuff. You can, if like there's some teachers that make you go A equals 5, B equals... You can if you want, whatever works for you. For me, maximum bang for minimum buck. And then the next thing that I always did, I don't know why, but I found it cut down on my dumb mistakes. For those of you that haven't had me before, I always say, I never make mistakes. And kids go, he made a mistake on the word mistake. That's what I mean by mistakes. Those are the dumb ones that we want to avoid, like when you go 3 plus 2 is 6 because you multiplied instead of adding, and those things. Okay? So I've learned just writing out the quadratic equation, which is on your formula sheet. By the way, look up for 1 second. I have no problem if you did that. The only issue is the variable in this equation isn't an x. What's the variable in this particular equation? I'm just, because I'm a nerd, going to put I have to put a t there. I'm not going to take marks off. If, as a habit, you're so used to putting an x there, you do. I'm not going to freak about that. But for Pete's sakes, it's a t! X, here it is, back page. All your formulas are on the back page there. There's a whole math section, so that the right hand of the shrunken down, there's like a bunch of math stuff there. I think it's got area of a circle, stuff I wouldn't give you actually, but this is the old provincial exam one, how they set up the course. This is the formula sheet you got on the provincial, so I'll go with what they suggested. Then I plug stuff in. I found if I'm by myself, I actually say this out loud as I substitute it in. If I'm with people that I want to have friends with, I actually am chanting it in my head. I'm imagining myself saying it. So I'm going to do it out loud. And, be negative 7 plus or minus the square root of, I tend to, if I can, square the number in my head myself. If it's a decimal, I won't, but I know 7 squared is 49, so I'm going to write that. Minus 4 times A times C all over. The other thing that I tend to do, I'm very good with my 2 times table. I can multiply any number by 2, even if it's a yucky decimal, so I'll almost always just do the 2A in my head, because it's less typing on my calculator. Right, I mean, even, 6.39, I can double that one in my head, no problem. I'm pretty good. I think most of you can. Now, I've taught math for a while. Here is my, if you struggled with the quadratic formula, if you often got stuff wrong, here is my advice. The next step is not to solve. The next step is to type on your calculator and get that to a single number inside the square root. I would always then go 49 minus 4 times 5 times 2. I would get that. This one is 9. By the way, the fact that it's a perfect square tells you I could have solved this using factoring, but I'm showing the quadratic formula method. I would now quickly rewrite this as negative 7 plus or minus the square root of 9. By the way, I know the square root of 9 is 3, but I'll write it like that so that if it hadn't worked out evenly, Jordan, you know what it would look like. And now, did I go on a little calculator rant last class about the usefulness of having a calculator with like arrows and things? Because those of you that have cheap POS calculators, not mentioning any names, see, here's what I can do. First of all, is there a fraction in this question? Everybody say yes. Is there more than one number on the top? Brackets. Is there more than one number on the bottom? Don't need brackets. But I can go bracket, negative 7 plus square root. Now on my calculator, when I open a square root, it automatically opens a bracket, so I have to close off the square root, close off the top, and I get 1 root of negative 0.4. And you see, Rob, the really nice thing is now I can just go backspace, edit, and change the plus to a minus, and do that. You can survive with that. You can survive with your calculator just fine, but if you got 20 bucks kicking around, trust me, you're going to be thankful that you got a calculator that lets you backspace and edit. If you got 23 bucks kicking around, trust me, you'll be thankful that you bought a calculator that's got a built-in quadratic solver. There's your roots. Please try typing that in, and I'm going to pause for a second. B. What kind of an equation is this? It's a quadratic. How do I know, Tice?
Square.
Got a square. That simple, folks. Okay? It's got a square. Before I start, what do I have to do to solve a quadratic? Before I even start, make it equal to 0. Now, I have a preference, and this is just because I've done this for a while. You could move the 4.9t squared to this side, making it negative. I have learned whenever a is negative, I make stupid mistakes. I don't know why, but I do. So I tend to always keep the quadratic term, the squared term, positive, and I move all the other stuff over. Even if that means moving things all sorts back and forth. So I can do it in my head, and it's no extra work for me, it's just brain work. So I'm going to write this as 0 equals 4.9t squared minus 12t. And then I tend to go, okay, that's A, that's B. By the way, what's C in this question? 0. But also, by the way, this would also factor, and you could solve it. But I want, and if you want, you can certainly do more with this. I'm giving you kind of a one-size-fits-all, getting you there okay as best I can. So you know what? I'll just do that so I don't forget. C equals 0. Have we turned the page? Everybody say no. Did we turn the page? If we had, I would actually rewrite the quadratic formula. But do you all have it one line above? Like I think I see mine poking out. So since I have it sitting right there, I'm going to go straight to plugging in numbers. I'm going to say t equals negative, oh, what's negative 12? What I do, just to let myself know that I caught it, I'll often put the plus in front of it to remind. I didn't forget. I noticed it was a minus, minus, and a plus, so that when I'm looking later on, I'm like, ah, I caught that. Plus or minus the square root of b squared. What's negative 12 squared? 144. Minus 4 times a times c. And then often I'll extend my square root, and a habit I picked up to show the end of the square root, I always drop a little tail like that to show, because sometimes if it's a really long, complicated expression, you're not sure what's inside the square root and what's not. And then I heard somebody mutter, hey, there's a 0 there. You're right. You know what? I think what I would now do is I would say, well, that's kind of convenient, because negative 4 times 4.9 times 0 was nothing. I might even have not bothered writing that in the first place. I don't know, but all over. And I told you that even if there's decimals, I can times them by 2. 4.9 times 2 is what? I picked that on purpose. I actually started with the acceleration due to gravity. Yes, 9.8. I did that because that one shows up an awful lot, turns out. I told you your next step was to solve what's inside the square root. Hey, I have. It's 144, and I know the square root of 144 is 12. It works out evenly, but just in case it hadn't, I'll leave it there so you can see what I would do. Is there a fraction? Everybody say yes, yes. Is there more than one number on the top? Yeah, brackets. I would now go like this. Bracket 12 plus square root of 144, close bracket. Oh, and I got to close off the top because mine does a bracket for the square root, divided by 9.8. And one of your roots is going to be 2.4489. Oh. What do I round to, Mr. Dueck? How many of you last year in Physics 11 loved sig figs, thought sig figs were just the best thing and so much? Okay, I hate them. This year, I'm going to be very pragmatic. Give me all your answers to 2 or 3 sig figs. I'm fine. Don't give me 9. Don't give me 1. 2 or 3. So I'm going to go 2.45. Then, Rob, I'm going to backspace, change that to a minus, twiddle my thumbs while you're typing away, stretch a little bit while you're typing away. By the way, I wouldn't do this. My calculator has a built-in quadratic solver, and I'd use it every time. And I knew one of the roots was 0, but I just wanted to walk you through the whole procedure. That is quadratic equations. Give me 1 second. This is not homework, the sheet that I just gave you. It will be, but I'm really going to be assigning it on Monday. But if you know you're going to be really busy next week, you can start it. What you can, in theory, do now is section C, where it says quadratic formula, solve the following: A, B, C, and D. And I did attach the answers. If you don't work on it this weekend, because it's a sunny weekend, make sure you bring this back on Monday. And we'll continue on with formula manipulation, and we'll get tricky with it.